Imagine a place in the universe where the rules of physics seem to break down, where the very fabric of space and time twists and bends into a dark, mysterious void. Have you ever wondered what happens inside a black hole? This is one of the most fascinating and terrifying objects in the cosmos. But what exactly is a black hole and how does it work? A black hole forms when a massive star reaches the end of its life. Stars spend most of their existence in a delicate balance between gravity pulling inward and the energy from nuclear fusion pushing outward. However, when a star much larger than our sun runs out of fuel, it can no longer fight against gravity. The core collapses, and if the star is massive enough, the collapse continues until all of the star's matter is squeezed into an incredibly tiny point called a singularity. Around this singularity is the event horizon, the point of no return. Once something crosses the event horizon, it cannot escape, not even light, which is why a black hole appears black. Despite the name, black holes are anything but empty. They have an immense amount of mass packed into a tiny space, creating an intense gravitational field. The gravity is so strong that it warps space and time around it. Imagine placing a heavy ball on a stretched-out rubber sheet. The ball creates a deep dent, pulling anything nearby towards it. A black hole does the same to space itself, curving it so much that anything that comes too close spirals inward. But what happens if you fall into a black hole? It's a question that has fascinated scientists and sparked the imagination for decades. As you approach, you would experience something called spaghettification. The gravitational pull is much stronger at your feet than at your head, stretching you thinner and thinner, until you're just a stream of particles spiraling into the singularity. To an outside observer, though, time appears to slow down for you the closer you get to the event horizon. You would seem to freeze at the edge, never actually vanishing from view because the light from you is stretched into longer and longer wavelengths. Black holes also affect the space around them in surprising ways. They can spin, dragging space-time along with them. This process, called frame dragging, twists the fabric of reality itself. Some black holes even emit powerful jets of particles, blasting away from their poles at nearly the speed of light. These jets come from matter swirling around the black hole in an accretion disk, superheated gas and dust that glows brightly before finally being swallowed. Interestingly, black holes aren't eternal. Physicist Stephen Hawking proposed that they slowly lose mass and energy through something called Hawking radiation. Tiny particle-antiparticle pairs constantly pop into existence near the event horizon. Usually, they annihilate each other and disappear. But sometimes, one particle falls into the black hole while the other escapes, stealing a bit of the black hole's energy. Over immense periods of time, this gradual loss could cause the black hole to evaporate completely. Even though black holes are invisible, scientists have found ways to detect them. They observe the effects of a black hole's gravity on nearby stars and gas, watching how objects move or light bends around what seems like empty space. Another groundbreaking discovery was the detection of gravitational waves, ripples in space-time caused by black holes colliding. In 2019, the first ever image of a black hole was captured by the Event Horizon Telescope, showing a glowing ring of superheated matter surrounding the dark silhouette of the event horizon. Black holes push the limits of what we understand about physics. They challenge our ideas about space, time, and the very nature of reality. They are not just cosmic monsters devouring everything in their path. They are crucial to the life cycle of galaxies and perhaps even to the evolution of the universe itself. So, the next time you look up at the night sky, remember that hidden among the stars are these dark enigmas, silently shaping the cosmos in ways we are only beginning to comprehend.
Got a question about how something really works? Drop it in the comments and we might cover your topic in our next video.